Welcome back, learners. We meet once again in our lesson 4 under our beautiful topic, electrostatics. Welcome back to Age Blush. Mr. Sylvester welcomes you, and I hope we have rested a bit and we are prepared to get into our calculations. Now, in our previous lesson, let me take you back a little bit to our previous presentation so that we can always connect and link these presentations. In our previous calculation, we were looking at three charges, linear charges, which are in a straight line, and we're supposed to calculate net electrostatic force. Now we are still going to calculate the net electrostatic force, but now we are dealing with charges which are at an angle, right? Which is actually a right angle. So I'm going to give you an example and I'm going to calculate it for you. Um, Suppose we have got the following charges arranged in that manner, where I've got my charge 1 like that. And let's say my charge 1 is -4. Let me use nanocoulomb, right? It is also, we have got also charge 2, right? Uh, which is plus 3 nanocoulomb. And then I've got my last charge, which is charge 3, like that, which is, let's say, minus 6 nanocoulomb. Now we have got those three charges, and let me put the distance between them. The distance between charge 2 and charge 3, let's say it's 2000 millimeters, right? And the distance between charge 1 and charge 2 is 1500 millimeters, right? So that is the scenario, that is the arrangement that we have. And our question says, what is the net electrostatic force? What is the net electrostatic force? Net electrostatic force. What is the net electrostatic force on Q2? All right. Yes, on Q2 due to the other two charges. Due to the other two charges. And we know that these other two charges, we are referring to charge 1 and charge 3. Right. What is the net electrostatic force? Now, this is slightly different from our previous calculation, where we are supposed to just calculate electrostatic force between Q1 and Q2 and the electrostatic force between Q3 and Q2, and then we sum up them, also considering direction. This one, Q2 is at an angle, so we need to apply more of mathematics also and a bit of our vector knowledge so that we come up with a proper calculation. Now, the first thing, let's do first things first, we need a free body diagram. So I'm going to draw a free body diagram. Allow me, friends, here to divide this page into two so that my calculation can fit very well without any hassle, right? So I'm going to divide it into two parts. So I draw a free body diagram here. I put a dot, and this dot represents Q2. Now I look at the relationship between Q1 and Q2. Q1 is negative, Q2 is positive, which means attraction is going to take place, right? So Q1 is going to be pulled down and Q2 is going to be pulled up. So we are worried about the movement of Q2, right? It's more like the frame of reference, our charge of reference here, or our reference charge, right? So Q2 is going to be pulled up. So we indicate that on our free body diagram or a force diagram like that. So that is going to be our F Q1 Q2, right? Then I look at the relationship between Q3 and Q1. I realize Q3 is negative, Q2 is positive attraction. So Q3 will move to the left and Q2 will move to the right. So again, we are worried about our reference charge, which is Q2. So it's going to be attracted to the right. So I'm going to indicate like this. So this is going to be FQ3Q2 like that. So that's my free body diagram. All right. Then from there, I need now to be able to determine FQ1, Q2, FQ3, Q2 using the formula which is the Coulomb's law. Right. Then FQ1, Q2 is equals to KQ1, right? Q2 over R squared. So my FQ1, Q2 is equals to our K, which is the constant. It's 9,0 times 10 to the power 9. You close. Our Q1, it's 4 times 10 to the power minus 9 because it's nanocoulomb. Right. And my Q2 is 3 times 10 to the power minus 9. You close. Everything divided by my distance between Q1 and Q2. It's 1,500 millimeters. We have got 1,000 millimeters in 1 meter. So you divide by 1,000. So 1,500 divide by 1,000, or we multiply by 10 to the power minus 3. You get 1,5. Don't forget to square. So FQ1 Q2 is equals to, I need my calculator again. I go straight to the fraction. Then I open twice as usual. Then I've got 9 times 10 to the power 9, which is my constant. I close, I open 4 times 10 to the power negative 9. Right, I close again. I open, I've got 3 times 10 to the power negative 9. Then okay, let me do this. I close, right? Then on the distance I open, it's 1 comma 5. I close, I square, and then gives me everything gives me 4 comma 8 times 10 to the power minus 8 newtons, right? Good. Then I have to determine also FQ3, Q2, right? Quickly, FQ3, Q2 is equals to KQ3, Q2 over R squared. Um, okay, so FQ3, Q2 is equals to 9,0 times 10 to the power 9. You close. Q3 is 6 times 10 to the power minus 9. I close. Then Q2 is 3 times 10 to the power minus 9. I close. And then everything is over. That should be 2 meters. You divide by 1,000 or you multiply by 10 to the power minus 3. So you get 2 and then you square. So my FQ3 Q2 is equals to, I need my calculator again. Right, then I need that fraction. I open twice and then I put 9,0 times 10 to the power 9. I close, right? I open 6 times 10 to the power minus 9. I close, right? I open 3 times 10 to the power minus 9. I close over. I open 2. I close, and that squared. Then I'm getting 4,05 times 10 to the power minus 8, and this is newtons. Right. So what do I do now? I need my free body diagram again and apply some vector knowledge. I'm going to do the tail to head method here so that I come up with a triangle, and the hypotenuse of that triangle represent our resultant force. Right. So I redraw the free body diagram again. Let me try to use a ruler so that I can come up with a nice diagram. I put that one there. So that one is my original FQ1, Q2, FQ1, Q2. Then I put my, all right, there, that this represents my FQ3, Q2, right? So I do tail to head method. I take the tail of FQ1, Q2, I put it on the head of FQ3, Q2, right? So these two are parallel. These two are parallel, and by virtue of being parallel, it means they are equal. That is a principle. So I draw it here. That's tail to head method. So this also represent FQ1, Q2, right? So what do? I go to the origin of my free body diagram. I draw a vector from there straight to the head of FQ1, Q2 there, and that represents our resultant force or our net force. So you can write F res here. Now, from your knowledge of mathematics, that is a right angle triangle, Pythagoras theorem can work. Yes, Pythagoras theorem there, it can work. So in other words, I can say f res squared is equals to fq1 q2 squared plus fq3 q2 squared. Right. Now, because of space, I'm going to jump another stage so that I just quickly substitute there and get my answer. So f res is equals to square root, right, of what is my fq1, q2? I've calculated it. It's 4,8 times 10 to the power minus 8. You close, this is squared, right? Plus, what is fq3? Q2, it's 4,05 times 10 to the power minus 8. You close, you also square. That is going to give us our resultant, which is our net force. All right. So therefore, F res or resultant force is equals to, now you need a calculator and you need to be very vigilant here. So this is going, I'm going to open my square root sign, and I open twice with a bracket. Then I've got 4,8 times 10 to the power minus 8 times 10 to the power minus 8. I have to close, friends. As I close, I must also square. This is plus, right? I open again. I've got 4,05 times 10 to the power minus 8, right? I close, I also square, right? And then I close for the last time. So I am going to get that answer, which is 6,28 times 10 to the power minus 8, and this is newtons. So that is our answer. That is our answer. So this is how you do it when you are dealing with three charges which are at an angle. So simple and so straightforward. So you just need to monitor your calculator. You just need to make a close follow-up to your calculation so that you don't lose it along the way. Let me just run through the explanation again for maybe for those who might have lost it somewhere, somehow. Number one, When you are presented with that kind of a question, you must come up with a free body diagram. And as you come up with your free body diagram, you must, as you come up with a free body diagram, you must remember that your charge is supposed to be in coulomb, and then you look at the sign of the charges. So let me just quickly rush through the diagram again. When you look at Q1, it's negative. Q2 is positive, so it's attraction, right? Because remember, initially we said unlike charges, they attract. So it means Q1 is going to be attracted, it moves downwards. And Q2 is going to be attracted upwards. So we are not worried about Q1, we are worried about Q2 because that's our reference charge. So Q2 goes up, right? So the effect of Q1 on Q2 is attraction. So Q2 goes up. So you indicate that force going up. And then you ignore that. You look at now the relationship between Q2 and Q3. Q3 is negative, Q2 is positive again, unlike charges attract. Q3 is going to be attracted to the left. We worry less about Q3, and Q2 is going to be attracted to the right. So it's going to migrate towards the right. And we indicate that on our free body diagram because our reference charge is the one that we follow its movement. So you're going to have your free body diagram. Then you use your Coulomb's law to calculate FQ1, Q2. You use your Coulomb's law to calculate FQ3, Q2. Then when you get your answers, you go back to the free body diagram. You use the tail to head method. That's our vectors that we did in term one in our syllabus. You use the tail to head method. You take FQ1, Q2, you put that the tail of that vector on the head of Q3, Q2, and then you complete the triangle. Your hypotenuse is your resultant force. Then there you apply your Pythagoras theorem. You get your resultant, and then that will be your answer. So in our next video, I'm going to show you how to determine theta. Let me just indicate theta on the diagram so that next time you know what we are looking for. We are going to look for that angle that is going to be our theta. So I'm going to show you that in our next video. Thank you so much for watching, and thank you so much for supporting Edge Blush. You are part of the family. We meet again in our next presentation. We love you all.